Hello everyone and welcome back to another VeedConf. I'm Evan Yu, the creator of Veed, and I'm really excited to have you here with us online again. And I've got some big news to share with you, and it's about Veed and the future of JavaScript tooling. So let's get right into it. First of all, a customary look at the NPM downloads. We've passed 15 million weekly downloads. That's more than double compared to last year's VeedConf. And just a few days ago, we had a single day with more than 3 million downloads. Pretty amazing. On the other hand, Vitess is quickly replacing Jest as the go-to JavaScript test runner, crossing 6 million weekly downloads of its own. In the latest State of JS survey, Veed and Vitess topped the charts in almost every applicable category. Most adopted, highest retention, highest interest, and most loved library overall. I was really pleasantly surprised when the results came out, so thank you to all Veed users for the love. And we have a vast ecosystem that keeps growing. Veed is now the default tooling for most frameworks when building an SPA, and powers almost every JavaScript meta framework except Next.js. Veed-based frameworks are now powering some of the most high-profile applications and websites in the world, ranging from OpenAI's ChatGPT to Shopify, Reddit, Porsche, Linear, and many more. It also has first-class integration with tools like Storybook and backend frameworks like Laravel. The significance of this convergence, in my opinion, is that frameworks building together on top of Veed can share a strong interop story. Not only can they avoid reinventing the wheels assembling a custom build stack, they can also share plugins, test runners, and even deployment adapters, allowing each framework to focus on innovation in areas that really matter. Saying this last year might have been a bit premature, but today I think it is fair to claim that Veed has become the shared infrastructure layer for the next generation of web applications. With all that said, I would be the first one to acknowledge that Veed isn't perfect. The trust that the JavaScript community has placed on Veed has pushed me to think deeply about its flaws, its future, and what we should do about it. I came to a pretty ambitious conclusion, and I want to go through my thought process with you today. Let's start with why people love Veed. People love Veed because it makes web development feel simple again. Note that this implies at one point, everyone felt web development was becoming too complicated. And it's true. Veed is hiding a lot of complexity from its end users under the hood. Internally, there are many things we wish we could simplify, change, or improve. We're only able to handle all that complexity thanks to the underlying tools that Veed is built on top of. Mostly ESBuild, Rollup, and SWC. ESBuild is used for dependency bundling, transforming TypeScript, JSX. It's also used for target lowering, syntax lowering transforms, and minification in the production builds by default. Now, Rollup is used for production bundling, and we use Rollup, a Rollup-compatible plugin system. SWC is not really needed by default, but if you're building a React app and want faster React refresh transforms than Babel's, you should be using the SWC-based React plugin that we provide. So when you're using that, you're effectively going to be using all three of these dependencies through Veed in one single application. Now, this architecture works, right? It's been working pretty well for a lot of you, and we are grateful that these tools allow Veed to delegate all these hard problems to them. But it has very glaring problems, and let's go through them one by one. First, I need to explain why we need two bundlers in the first place. We use ESBuild, which is blazing fast, but its tree shaking and code splitting are not as complete and configurable as Rollups. And its plugin system is a bit too rigid compared to Rollups. So we only use it to bundle dependencies during development. This is called the dep pre-bundling or the dep optimizer as we know it. By default, we also use ESBuild as a transformer to transform TypeScript, perform syntax lowering, as I just mentioned, and minify chunks during production. We use Rollup for the production build because it is better suited for bundling applications compared to ESBuild, given that it has better chunky control and a bit more flexibility in configuring the tree shaking behavior. However, Rollup is written in JavaScript. While the bundling performance is better than Webpacks, it is much slower compared to bundlers written in a native language. For example, ESBuild. And for SWC, one of the reasons we don't really include SWC in Vite by default is because it's heavy binary size. On macOS, the binary is 37 megabytes, and that's more than twice the size of Vite and all these dependencies combined. And while SWC has comprehensive transforms and a high-quality minifier, it doesn't really offer a usable bundler. So even if we include SWC, we still need to use another bundler to cover the other parts. So we are unfortunately stuck with this multi-dependency scenario. The first problem that this leads to is behavior inconsistency. There can be difference in the ways ESBuild and Rollup handle mixed ESM and CJS module graphs. And sometimes this can lead to subtle bugs that can only be discovered after production build goes live. Not good. Second is the massive inefficiency in the build pipeline. The same piece of source code in a Vite production build gets repeatedly parsed into AST, transformed, and serialized back into strings by these different tools. And worse, they're often passed back and forth between native side, for example, the Go process, and JavaScript main thread, and then passed to Rust, and then passed back to JavaScript. So all these passing these large chunks of data across processes also has a lot of overhead. And it gets even worse when source maps are enabled, because every individual step between these tools requires remapping of the source maps and merging them. Finally, the unbundled native ESM dev server works great, but only up to a certain threshold. The network overhead, when you need to load tens of thousands of unbundled modules over HTTP, really adds up. And it can take seconds for a page to load during development. While probably 90% of apps we're building are not this big, but the development experience for that other 10% becomes problematic compared to a fully bundled approach. Unfortunately, in the current model, we don't have a good solution for this. We wish we could use a bundler to do full bundling during development too, but ESBuild is incompatible with our plugin system and will result in even more development production inconsistencies, while using Rollup will just simply make it too slow. So, sounds like we need to unify the bundler used in Vite by building one ourselves. And that is exactly why we started Rowdown. But before we dig into Rowdown, I thought a bit more. As we worked on Rowdown, I dig deeper into the idea. I found that even the abstractions below the bundler layer have similar problems. So why do we stop at the bundler? I realized that the challenge Vite is facing is really a reflection of the JavaScript ecosystem at large. JavaScript grew from a simple scripting language to literally the most widely used language in the world today. During this process, the JavaScript community created many different tools to bridge the gap between its lack of official tooling and the rapid growth in the scale and complexity of its use cases. We're building more and more ambitious applications, and we had to create all these tools just to scramble to keep up with the demand of all these engineering best practices and newfound complexity and the requirement to have types, the requirement to bundle, minify, and everything. We discovered these problems along the way and created tools to solve them along the way. This is a blessing and a curse, because the JavaScript ecosystem is probably the most vibrant community out there. There are so many innovations, so many great tools that came out. It did give us all the tools we needed. But it also gave us a new set of problems. That is fragmentation, incompatibilities, inefficiencies, and in many cases, frustration. My conclusion is that to eliminate the inconsistency and inefficiency issues, a unified toolchain for JavaScript is needed. It starts at the parser and includes semantic analysis, transformer, linter, formatter, minifier, bundler, all the way up to the common layer of abstraction that supports the final frameworks. And that common layer is Vite. And this is also what I believe this toolchain should be: unified, high performance, composable, and runtime agnostic. First, unified. All the different tasks involved in the process of turning source code into final build artifacts should be performed by the same set of tools using the same AST, with the same consistent rules for configuration, module format interop, and path resolution. Second, high performance. For well-defined tasks like transforming TypeScript or bundling code, the tool should be written in a compiled to native language with an obsession for performance at every possible chance. Given JavaScript scale today, performance improvements in our tooling is a huge leverage that speeds up not only dev cycles, CI builds, product delivery, and ultimately saves money for everyone. Third, composable. The toolchain should be composable. Each component of the toolchain should be individually consumable as a dependency. For example, the parser, the resolver, and the transformer should all be usable as Rust crates or NPM packages. There should be efficient Rust.js interop so that users, while leveraging these native tooling, can still write JavaScript plugins to fit their needs. And finally, the core of the toolchain should be runtime agnostic. Developers trying to leverage these tools, or just a part of the toolchain, should not be forced to lock themselves into a specific JavaScript runtime. We want the same development experience no matter what runtime or target environment you are targeting, as long as you're writing JavaScript. Now, you might be thinking, isn't this just way too ambitious? Well, I used to think so too. Some other folks have even tried and failed. But think about it. 4 years ago, who would have believed that Vite would become the convergence point for JavaScript frameworks as it is today? Well, I believe if we have the right people, the right execution, the right leverage, and enough resources, this goal, despite it being very ambitious, is indeed possible. So this is why I started a company called VoidZero, a company building the next generation of JavaScript tooling. We have raised 4.6 million seed funding, led by Accel, with participation from Amplify partners and many experienced founders in the DevTools space. We have built a full-time team that is working hard to realize this vision. Now, here is a big picture overview of what we are building at VoidZero. OXC will be the foundational language toolchain that supports everything. It includes the parser, semantic analysis, transformer, minifier, resolver, linter, and formatter. Rowdown is the bundler built on top of OXC and will be the unified bundler powering a future version of Vite. Through Vite and Vitest, we will be moving all frameworks and tooling depending on them to a unified foundation. So, let's talk about the progress so far. This is the progress chart for OXC. For OXC, we have already completed the parser, linter, and resolver. Boshan, OXC's project lead, will actually talk about this in more details, so I'll be a bit brief here. For the transformer, we've already completed TypeScript, JSX, React Refresh transforms, and isolated declarations for TypeScript DTS emit. Our current focus is on finishing the transformer with syntax lowering transforms. The minifier and formatter are in working prototype state and will be worked on after the transformer is done. And now, how fast is OXC? This is the meaty part. To the best of our knowledge, we're proud to say that it's probably the fastest in every comparable category out there so far. It has the fastest parser, the fastest linter, the fastest resolver, and the fastest transformer, or up to 3 times faster than other Rust-written solutions. I have linked the benchmarks, and you can check them out yourself after the talk via my shared slides. There are some other often overlooked metrics I'd also like to mention about OXC. First of all, it uses much less memory than, for example, Babel. It also uses less memory than SWC. And it also ships significantly smaller binaries compared to other solutions. Remember I mentioned the reason we didn't want to include SWC by default in Vite was because of the binary size. So OXC transform, when used as a NPM dependency, downloads the respective binary for the target platform, and on macOS the size is only 1.95 megabytes, less than 2 megabytes, and that is, well, almost 20 times smaller than SWC size, right? And if you use OXC as a Rust dependency, as a Rust crate, it also compiles much faster because it doesn't rely heavily on macros. So that also improves your development experience if you're using OXC as a Rust developer. Now, on to Rowdown. For Rowdown, we have already completed most of the features you'd expect from a bundler. Notably, CJS and ESM interop, source maps, output formats, basic code splitting, CLI, config file support, and all that. Typical things you'd expect from a bundler. But on top of that, we also have OXC integration, which means Rowdown actually ships with built-in TypeScript and JSX transforms, built-in Node-compatible resolving, built-in alias handling, and everything that you expect from a fully featured resolver. And it also has finished some advanced features such as production quality tree shaking, advanced chunk splitting options, which is actually more powerful than rollups already. And we have reached 90% compatibility with rollup plugins. Only some niche options and properties are not supported. And it can already run a good chunk of official rollup plugins, unless it relies on some specific properties that we do not support. So right now, we are focusing on two things for Rowdown. The first is making Rowdown a general purpose bundler that has first-class support for CSS, HTML, and assets. And the other is testing its integrations into Vite, replacing ESBL rollup and porting some of the Vite internal plugins over to Rust to reduce overhead. This work in progress Rowdown Power Vite, which we currently just call it Rowdown Vite, currently passes 98% of dev tests and 82% of build tests. So we're on a very good trajectory to complete the test coverage and then start releasing it in alpha state. Once we finish these two, it will be some more behavior alignment, performance tuning, and code quality polish before we release Rowdown as a 1.0 beta. To get an idea of the performance of Rowdown, we used a benchmark forked from another bundler, and we increased the number of components the benchmark contains. So in our version of the benchmark, we're bundling 19,000 modules, where 10,000 of them are React.jsx components and 9,000 are Iconify.js files. Now, Rowdown completes the bundle in 0.63 seconds. That is almost 2 times faster than ESBuild, and 3 times faster than Farm, and 5 times faster than RSBuild. Note that we don't even include JavaScript bundlers in this benchmark anymore because the bar would literally go out of the screen. And if we try to bundle this application with the current rollup-powered Vite, it actually just runs out of memory and never finishes. Another case study that is a bit more real-world is using Rowdown and OXC to bundle Vue. Now, Vue's codebase is a pretty non-trivial codebase. It's a TypeScript monorepo with 11 packages and 62 dist bundles. There are cross-dependencies between these packages. We use TypeScript everywhere, and there are a pretty complicated cross-package dependency graph and some pretty custom pre-built steps that we have. So we actually, being able to migrate over from our previous rollup-based build setup over to Rowdown, actually simplified the config by quite a bit because there are multiple plugins we were able to remove that are supported just as built-in features by Rowdown. Now, Notably, the bundle packages and TypeScript declaration, now using Rhodan and OXC's isolated declarations DTS emit transform, are passing not only Vue's own tests, but also Vue's ecosystem CI tests, where the build artifacts are tested in the real build and test flows of a dozen downstream Vue ecosystem projects. So this is a good testament for the production readiness of Rhodan and OXC in general. Although we don't really consider them production ready yet, we consider being able to pass Vue ecosystem tests a very, very good milestone that we can use to verify how ready it is. Now, because successfully passing all these tests required correctness in every aspect of the pipeline, including transforms, platform and format output, plugin compatibility. Also, the pre-minified bundle size are matching that of the output of Rollup, which means there is comparable tree shaking and dead code elimination quality. And of course, the performance. Here we are comparing 3 versions of Vue, three commits at different times. 3.2 were about 19 months ago when all the tooling that we used were written in JavaScript. And it was also inefficient because we were essentially generating DTS for each package individually. Now, in 3.5, the current main branch, actually probably in 3.4, we did a major build refactor. We migrated over to ESBuild using Rollup plugin ESBuild to do the TypeScript transforms. We are using SWC for minification, and we moved over to Rollup plugin DTS for DTS bundling. So that was actually a big round of optimization, but the main bundling was still using Rollup because it was the only one that was able to retain the same bundle size in the production builds due to the tree shaking requirements. So in Vue 3.5 main branch, the current full build time take, including types, is 8.5 seconds. Sorry, compared to the 3.2, close to 2 minutes. That's already a pretty big improvement. But now, after migrating to Rhodan and OXC transform for the DTS emit, the whole build takes a little bit more than 1 second. And this is not even the most optimal form yet, because right now we are doing the DTS emit and bundling in a separate process in the second step. In the future, Rhodan will include the DTS emit and bundling as a built-in feature that's going to be performed in parallel to the source code bundling. So when that happens, the whole build process for Vue will be well below 1 second. So that is the progress so far, and what's next? So first of all, let's take a look at V today. This is V today. This is showing the architecture of the upcoming V6 with the environment API merged. It still relies on ESBuild, it still relies on Rollup, and if you're using React, you want fast, refresh, transform, and you don't want to use Babel, you will still be using SWC, right? So this is V today, and in the worst case scenario, you'll be using 3 different tools that's wrapped inside Vite. This is the next evolution of Vite, and its current work in progress, as will be known as Rhodan Vite. It is powered by Rhodan and OXC internally. It will greatly improve the dev product consistency because now there's just one toolchain that handles both development and production bundling. It will reduce the internal overhead because there's just less code passing between different tools. And it will greatly improve the production build performance because Rhodan is written in Rust and is blazing fast. So this is going to be the version that we'll be focusing on right now, and we hope to get it into your hands early next year. And in the longer future, we will likely ship a version of Vite that delegates even more to Rhodan. And we use the same bundling capabilities of Rhodan for development, environment module runner, and production. So this allows us to get rid of the unbundled network bottleneck for extremely large applications. It will also ensure maximum consistency across browser environment, simulated Node.js server rendering or worker environments, and also for production builds. It will provide the best possible performance in all of these scenarios, and also gives you a consistent toolchain that handles all the tasks together. And this is our long-term goal. Currently, it's in prototype stage because the first thing we want to do is to make sure that the full bundle mode can actually work, and we can actually also have HMR on top of a full bundle emitted by Rodan. And the full bundle mode performance prototype is, again, very promising. From the benchmark, using the same React JSX-based mock application, we can see that the page load is more than 5 times faster compared to today's Vite, compared to the unbundled version of Vite. And the HMR is also close to instant with some optimizations on the watcher side. So that said, this is still early. Our current priority is to ensure the existing Vite ecosystem can smoothly start benefiting from our work on Rodan and LXC. And this process is going to take some time. We'll be working on this future version of Vite in parallel, and we hope to also be able to show you a more stable version of it later next year. Well, that's it. I hope this gets you excited about the future of Vite and JavaScript. We wouldn't have had the courage to take on this challenge without the trust and support from the Vite community, and we hope this work will make us all more productive and result in more great apps being built faster. Thank you.